I am Anil Kumar, sharing with you some test questions which can help you perform much better. Let us go through these solutions one by one. Enjoy the journey of learning. Here we have an excellent example based on the derivatives of exponential functions. Y to the power of x is equal to x to the power of y. And we are also given that dy dx is ln a minus c divided by ln b minus d. Find the values of a times b times c times d. Four choices are given to you. You can pause the video, answer the question. Some of you can also contact me on email if you want to learn directly and be the best. Now, let's look into the strategy which we can adopt to solve such questions. We are given that y to the power of x is basically equal to x to the power of y. Bases a different, difficult exponential equation which looks very simple. What we can do now is take log both sides. So if I take log both sides, I can say ln y to the power of x equals to ln x to the power of y. So that basically becomes x times ln y equals to y times ln x. Now, it is easy to differentiate, right? So let's differentiate with respect to x ln y on the left hand side. We can apply the product rule, right? So if I apply the product rule, what do I get? Derivative of x times ln y, right? So d dx of x times ln y plus x times derivative of ln y equals to, on the right hand side, we get d dx of y times ln x plus y times d dx of ln x. Correct. So derivative of x is 1, and therefore we could write this as ln y plus x times derivative of ln y will be 1 over y dy dx, implicit differentiation, correct? Derivative of y will be dy dx times ln x, right, plus y times derivative of ln x, which is 1 over x. Now at this stage, we can bring dy dx terms to one side and the other terms on the other side. So dy dx, we have, bringing them all to the left, we get dy dx, we have x over y, and if I bring dy dx, we get minus ln x here, right? Equals to, here we have y over x minus ln y. So dy dx, we get a term which is y over x minus ln y over x minus y over ln x, right? But in the given expression, we have ln a minus c. Well, it makes, it's kind of similar, right? So we could write dy dx as equal to what? So we can flip them both sides, right? So let me just take it to the next page where we'll write y over x minus ln y divided by x over y minus ln x, right? So we get dy dx as y over x minus ln y over x over y minus ln x. And this is also same as If I multiply by minus both sides, I could rearrange and write it at ln y minus y over x over ln x minus x over y. Now we can compare the terms, right? So a for us is equal to y, b, which is x, c is minus y over x, minus c will be y over x, and d will be x over y. We need to find what is the product of a, b, and c, right? C, d, right? So let's multiply them. So a times b times c times d. A is y times x times y over x times x over y. Perfect. So from here we can cancel x and we can cancel y, and we're left with xy. So option A is the correct option, and that is how we are going to solve this particular question. I hope you find it interesting and useful. So logarithmic derivations is very easy to understand and apply. But once you do that, you can solve very difficult questions. I hope it makes sense. I'm Anil Kumar. Here is a question from one of our subscribers. The following diagram shows graph of f of x equals to 6 minus 3x times 4 plus x, where x belongs to real numbers. The shaded region R is bounded by x-axis, y-axis, and the graph of f. Write down the integral for the area of the region. Find the area of the region R, right? So that's the question. So let us see how do we solve such a problem. So what we are given here is the function f of x, which is equal to 6 minus 3x times 4 plus x. To write down the integral, we need to figure out from where to where. So one point is very clear, which is x equals to 0. The other one we need to find. So basically, you need to find the x-intercept, right? So for x-intercept, y is 0. Just equate y equals to 0 here and find the x values. So from 0 multiple theorem, we can say that the two factors should be 0. So 6 minus 3x should be equal to 0, which gives you 6 equals to 3x, or 6 by 3 equals to x, which is 2. That is one value, right? The other one is 4 plus x equals to 0, x equals to minus 4. So we get two values. This one is minus 4, and the other one here is at 2. Now from the shaded region R, we know R is between the values, which is 0 and 2. So that's the area which we need to find. Clear? So now we can write down the integral, and that has to be from 0 to 2 with the function which is 6 minus 3x times 4 plus x dx. So that is the solution for part A, where we need to write down the integral for the area of the region R. Is that clear to you? Perfect. Now we need to, in part B, find the area itself. To find area, it will be a good idea to expand and simplify this particular expression and then use the integral, right? So let's do it on a fresh page. So I hope so far there are no issues, right? So we have found the area for the region R. Formula is given to you. Now let's calculate, right? So area is between 0 to 2. We know this is 0 and this is 2, right? And the function is 6 minus 3x times 4 plus x dx. So let's expand 0 to 2. So we get 6 times 4 is 24 minus, or 6 times x, let's write 6x first, then minus 12x and minus 3x squared. And that gives you the area from 0 to 2. Let's simplify this. We can write minus 3x squared and x, we got minus 6x plus 24. And we can use the power rules to find the integral itself. So minus 3x squared gives you minus 3x cubed over 3, right? Minus 6x gives you minus 6 times x squared over 2 plus 24x. And we are looking at 0 to 2. Is it clear to you, right? Okay. Now, let's substitute the values. So if I substitute, let me write this as the integral or the area, right? Let me write R, right? Area of region R. So it is now, when I substitute 2 here, well, we can calculate this, simplify this a bit, right? So let's simplify this a bit. Area is always positive, so we are just putting absolute value type also. So we got minus x cubed, and here we have minus 3x squared plus 24x from 0 to 2. Clearly, if I substitute 0, all will be 0. So what we're looking at is substitute 2 here, right? So minus 2 cubed minus 3 times 2 square plus 24 times 2. Absolute value, right? So we got minus 8. Here we have 4 times 3, which is 12, minus, and this is 48. And that gives you, so we can take away 20, right, from 48, and that gives you 28. So the area is 28 units square, correct? So that is how we'll find the area of the shaded region in this particular case. I hope that makes sense. The function f of x is a cubic function, 1 over 3x cubed plus half x squared plus kx plus 5. And it has a local maximum and a local minimum. The local maximum is at x equals to minus 3. Two parts. First is find the value of k, which is not given to you in the function. And part B is find the point where the graph of f has a minimum, right? So let's change this. So find a point where the graph of f has a minimum, right? So we are given the maximum, so that's the second thing which we need to find. So let's try to work on it. Basic concept is that at maximum or at minimum, the derivative should be what? The derivative should be 0, right? So first thing is we need to find the derivative. Great. So let's begin with the function itself, which is f of x equals to 1 by 3 x cubed plus half x squared plus kx plus 5. Derivative applying the power rule will give 1 by 3 times 3x squared plus half times 2x plus k. Let's simplify this. So we get here x squared plus x plus k, right? Relatively simple derivative. And now we want to find the value of k, and for that we are given a condition that the local maximum is at x equals to minus 3. So the condition is that local maximum at x equals to minus 3. So it means that the derivative of the function at minus 3 should be equal to 0. That is what it means, right? So the derivative is minus 3 means, let's substitute minus 3 for x and see what. So f of minus 3 equals to 0. Substituting minus 3, we get minus 3 square plus minus 3 plus k, right? Rearrange, so we have 0 equals to 9 minus 3 plus k, which is 6 plus k, or the value of k is minus 6, right? So we got the value of k. So that really means that we can now write the function f of x as 1 over 3 x cubed plus half x squared plus k is minus 6. So we'll write minus 6 here, right? Minus 6x plus 5. Perfect. So that is what the function is. And we found the value of k as minus 6. Correct. Let's do the second part on a fresh page. So we need to find the point where the graph of f has a minimum, right? This is a cubic function, positive leading coefficient. So something like this, right? So we already know that this point where it was a maximum, it was at x equals to minus 3. We need to now find the point where it was minimum. So what we can do here is again find the derivative. We could use the derivative found earlier also. So let me rewrite the function once again. So we have the function as k is minus 6. Now we know it, right? So the derivative of this particular function is going to be 3 times 1/3 x squared, 2 times half, which is 1, so we get x. And here we get minus 6. We want this to be 0. That's what we need. And we need to find the value of x. Since we are looking for the minimum now. So means horizontal tangent. That's what the concept is. So this equation is relatively simple. We can factor product of 1 and product of minus 6 and sum of 1. So that means 3 and 2 can work, right? Plus 3 and x equals to minus 2. I mean x minus 2, correct? So that gives us 2 points. One is x equals to minus 3, the other one is x equals to 2. So we already know that at minus 3 we have a maximum. So the other point is minimum, right? So we can say we need to find the point. So we can now plug in 2 and find the value also, right? So if I plug in 2, we get 1 over 3, 2 cubed plus half 2 squared minus 6 times 2 plus 5. Okay. So that will give us the y value, right? So we can calculate this y value, 8 over 3, right? So we have 8 over 3 plus 4 over 2 is 2, right? Minus 12 plus 5. So that is, let's add them up. So we have 5 plus 2 minus 12, and then to this we'll add 8 over 3. And what we get is minus 7 by 3. So in this particular question, since we are already given that the graph has a maximum and a minimum, and there are only two critical points, so we really do not have to verify that this is a minimum, right? However, you can verify this as a minimum by many different techniques. One of them is to find the second derivative, right? So let's find the second derivative just to confirm. So second derivative will be 2x plus 1. And at this point, which we figured out as 2, this was x equals to 2. If I find the value at 2, we get 2 times 2 plus 1, which is 5. And since it is greater than 0, so it is concave upright. That means it is a minimum, right? So as you can also see here, concave up means minimum, and that is how you're going to verify. So you could verify and confirm that yes, at this particular point, which is for us 2 and minus 7 over 3, we have local minimum for this particular function. So I hope that is absolutely clear. Consider the function f of x equals to x squared by 4. Find the gradient of the function. Find the gradient of the function f of x at x equals to minus half. Find the x coordinate of the point at which the normal to the graph of f has a gradient of minus 1 over 8. A very good question from foundation point of view. Let us see how do we solve it. So let's begin with the function given to us, which is f of x equals to x squared over 4. Now, derivative of this particular function is going to be 2x over 4, and that means it is derivative can be expressed as x by 2. So that is part A, where we are finding the derivative of the function. Right. So we have done this part. Second is find the gradient of the function f of x at x equals to minus half. So let's put x equals to minus half here. So gradient of this particular function at x equals to minus half really means we'll substitute the value of x as minus half, correct? So we get minus half over 2, and that is equal to minus 1 by 4. So the gradient of the function f of x at x equals to minus half is, let me write here itself, minus 1 by 4. Part C is find the x coordinate of a point at which the normal to the graph of f has gradient of minus 1 over 8. So part C is normal gradient is minus 1 over 8. So normal at that point is minus 1 over 8. How about the tangent? Slope is going to be 8, right? Negative reciprocal. So basically, we'll equate the derivative of the function, which is x by 2, as 8 and find the value of x. That's what it means. You get the whole idea, right? Solving this, we get the value of x as 8 times 2, which is 16, right? So that becomes the x coordinate of a point. So here we'll write x equals to 16 as our answer. Do you see how we can solve this particular question? So three parts, and these are the basic three steps: finding a derivative at a particular point, and finding a point where the gradient is given to us. In this case, normal was given to us, right? So I like you to practice and just practice with another function. Let's say we have g of x, which is x cube over 4, right? So try to do similar things with a new function so that you gain the confidence of understanding all these steps. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.